So hello everyone, I am Danica Grace Gahok and I am here to report the chapter 7 which is the network architectures. The last three parts was already reported and uploaded by Ms. Duff Kagan Rose Guide. So a network's architecture generally refers to its overall structure including the topology, physical media, and the channel access method. To properly access network technology implementation requirements, we must understand these topics. So I know you are familiar with the word Ethernet, but what really is Ethernet? So Ethernet is the most popular network architecture. It is a method in which a user connects several computers and share their data. It is a way of connecting computers and other network devices in a physical space. So the Ethernet is divided into three categories based on transmissions, speed, and media. The section that follow cover these categories. There are four major implementations of 10 Mbps Ethernet, and these are the 10 base 5, which is the Ethernet using thicknet coaxial cable, the 10 base 2, which Ethernet using thinnet coaxial cable, the 10 base T, which Ethernet over unshielded twisted pair or UTP cable, and the 10 base F, which is the Ethernet over fiber optic cable. Among the four Mbps standards, only 10 base T and 10 base F are commonly seen today because the other two are essentially obsolete. So the 10 base T Ethernet usually unshielded twisted pair UTP cable but also can transmit with shielded twisted pair or STP cable. The exceptionally low cost of both the media and equipment make 10 base T a bargain for networks that do not require higher transmission speeds. So the figure on the left side shows a 10 base T Ethernet network wired in a star topology, but 10 base T Ethernet networks use a bus signaling system internally. The table on the right side is the 10 base T Ethernet summary. So the IEEE specification for running Ethernet over fiber optic cable is 10 base F and is generally divided into three subcategories. And these are the 10 base FL, which used to link computers in a LAN environment, fiber to the desktop, the 10 base FP, which used to link computers using passive hubs rather than repeaters, and this category has maximum cable segment length of 500 meters, and the 10 base FB, which uses fiber optic cable as a backbone between hubs. Like 10 base T, the specification lists 1024 as the maximum number of nodes on a single network connected by repeaters. Because of its high cost, 10 base F generally is reserved for connections between hubs or for situations in which security requires cabling not easily affected by electromagnetic interference or EMI. So here is the 10 base F Ethernet summary. The most widely accepted Ethernet standard today is 100 base T, which is also called as the fast Ethernet. Higher speeds makes this technology well suited for applications such as CAD or computer-aided design, the CAM or the computer-aided manufacturing, and imaging. 100 base T, also called fast Ethernet, is an extension of the 10 base T standard. The current IEEE standard for 100 base T is 802.3U. These are the 100 base T4, which has a 4-pair category 3 or higher UTP, the 100 base TX, which has 2-pair category or higher UTP, and the 100 base FX, which has 2-strand fiber optic cable. When considering implementing fast Ethernet, it is important to remember the cabling requirements for each category. Although three cable types are available for 100 base T, 100 base TX is the most widely accepted and therefore is the standard generally referred to as Fast Ethernet. So here is the 100 base T Ethernet summary. Collectively, the IEEE identifies various gigabit Ethernet standards under the general heading 1000 base X. Because signaling methods at 100 gigabytes are so fast, they are also quite different from methods used for slower Ethernet technologies. Most gigabit Ethernet implementations, including network interfaces, switches, and other equipment, work in full duplex mode. Remember that two interconnections between a sender and a receiver are required when fiber optic media are in use. So two connections make it possible for both parties to send and receive. Because this capability is inherent in the medium, makes sense to use full duplex communications with such equipment so that both parties can send and receive data at the same time. 1000 base LX uses fiber optic media. The L stands for long wavelength, the kind of laser used to send signals across the medium. These long wavelength lasers operate at wavelength between 1270 to 1335 nanometers and work with single mode and multi-mode optical fiber. So the table below shows the 1000 base LX Ethernet summary. 1000 base SX uses fiber optic media. The S stands for short wavelength, the kind of laser used to send signals across the medium. These short wavelength lasers operate at wavelengths between 770 to 860 nanometers and work only with multi-mode optical fibers. 1000 base CX uses specially shielded balanced copper jumper cables. The C stands for copper, the kind of electrical signaling in use. Jumper cables are normally used for interconnections between devices or interlink VLANs on a switch. Such jumper cables may also be called PRINACs or short-haul copper cables. So the table below shows the 1000 base CX Ethernet summary. 1000 base T was formally released as IEEE standard 802.3AB in June 1999. It supports gigabit Ethernet over 100-meter segments of balanced Category 5 copper cabling and requires 4 pair of wires. 1000 base T employs special equipment called hybrids and cancellers to combine multiple signals and to cancel interference to support full duplex transmission over a single pair of wires. So if the link is operated in half duplex mode, the speed of the channel is 1000 Mbps or 250 Mbps times 4 wire pairs. 1000 base T Ethernet is gaining wide acceptance in corporate data centers to connect servers to the corporate backbone and as the primary connection type for storage area networks or SANs. So the table on the right side shows the 1000 base T Ethernet summary. Sometimes called Ethernet Raw, the Ethernet 802.3 frame type was developed before the completion of the IEEE 802.3 specification. The diagram on the side is a diagram of an Ethernet 802.3 frame. It begins with the preamble in a start frame delimiter SFD statement, which indicates the beginning of the frame. Greater numbers of computers and increased traffic back down most network implementation. One way to ease this problem is by segmenting the network into manageable pieces. So an Ethernet segment is a group of network devices connected to a single Ethernet gateway. The Ethernet part refers to the wired or physical connection within network components. Developed by IBM in the mid-1980s, the token ring network architecture provides users with fast, reliable transport. Its design uses a simple wiring structure with twisted pair cable that connects the computer to the network through an outlet into the wall. The majority of the wiring is in the central location. The figure on the left side is a token passing channel access method rather than the physical layout of the network gives token ring its name. In this figure, the other two ports are used to connect the hubs in a ring. The ring out or RO port on one hub connects to the ring in or RI port on the next hub, and so on to form a ring among the hubs. By using the token passing channel access method, token ring networks ensure that all computers get equal time on the network. A small frame called the token passes around the ring. A computer receives the token from its nearest active upstream neighbor or none. If the token is not in use at the time, no nearby computer is sending data, and the computer has data to send, it attaches its data to the token and sends it to its nearest active downstream neighbor or the NADN. One unique aspect of the token ring network architecture is its capability to automatically isolate faults by using a process called beaconing. So beaconing is a technique used on a token passing network for monitoring the status of the token passing process. Beaconing is used in token ring and the fiber distributed data interface or FDDI networks to ensure that token passing is functioning properly. As shown in the figure below, if a station does not hear from its upstream neighbor in 7 seconds, it sends a packet down the ring that contains its address, the address of its none, from which is received no packet, and a beacon type. When discussing hardware components of the token ring architecture, IBM equipment is most often used. In a token ring network, a hub can be referred to as a multi-station access unit, or MAU or MSAU, or a Smart Multi-Station Access Unit or SMAU. IBM's implementation of the token ring is the most popular adaptation of the IEEE 802.5 standard. In 1984, IBM defined a comprehensive cabling system that specified cable type, connectors, and all other components required for computer networking. This cabling system breaks cables into different types based on the American Wire Gauge or AWG standards that specify wire diameters. When token ring was introduced, it followed these standards for cabling and equipment. The table below shows the cable types including the IBM system and used by the token ring. And that's the end of the chapter 7, which is the network architectures.